Imagine looking up one night and seeing a strange dark spot moving across the stars. It isn't a shadow and it isn't a planet. It's a black hole drifting silently into our solar system. No light. No sound. No warning. Just gravity so powerful it could tear planets apart and bend time itself. What would happen if a black hole entered our solar system? The invisible invader. Black holes are the most extreme objects in the universe. They are regions of space where gravity has collapsed matter into a point so dense that not even light can escape. Most are formed when massive stars die and their cores collapse under their own gravity. Others, called supermassive black holes, sit in the centers of galaxies, millions of times heavier than our sun. But out there in the galaxy, there are also rogue black holes, smaller ones that drift alone through interstellar space. Invisible, silent, and deadly, they wander between the stars. Astronomers estimate there could be hundreds of millions of these dark travelers, and one of them someday could pass near us. First signs of trouble. At first, we wouldn't see the black hole itself. It gives off no light. But we might notice something strange. The orbits of distant comets in the outer solar system would start to shift. Some would be thrown off course, others pulled inward. Telescopes would detect subtle distortions in starlight, as gravity from the black hole bent space and warped the light coming from behind it. At first, no one would believe it. The pattern would seem impossible. But soon, every observatory on Earth would agree, an object far more massive than any planet is approaching from the dark. The black hole's approach. Let's say it's a stellar mass black hole, about 5 to 10 times the mass of our sun. It's moving at around 50 kilometers per second, a typical galactic speed. Even from billions of kilometers away, its gravity would start to disturb our solar system. The first to feel it would be the outermost regions, the Oort cloud, a vast halo of icy objects surrounding the sun. The black hole's passing would send millions of comets tumbling toward the inner solar system. Earth's sky would soon be filled with streaks of light as comets burn through the atmosphere. The risk of impacts would rise dramatically. The solar system would become unstable, its delicate balance starting to break apart. When it reaches the outer planets, as the black hole drifts closer, the outer planets would begin to feel its pull. Neptune and Uranus could be nudged from their orbits. Saturn's rings might twist and scatter. Jupiter, the largest planet, would try to hold its ground, but even its immense gravity would start to shift. The black hole wouldn't need to hit anything to cause chaos. Its gravity alone could distort orbits, stretching and pulling planets out of alignment. Tidal forces would heat up moons and atmospheres, causing violent storms. By the time it reached the region near Jupiter, the entire solar system would be trembling. What would happen to the sun? If the black hole passed close to the sun, the effects would be catastrophic. Our star might be pulled slightly off-center, or its outer layers could be disturbed. In the most extreme case, the black hole could start drawing in solar material, forming an accretion disk of glowing gas around itself. That disk would shine brighter than any star in the night sky, a brilliant ring of destruction. But if the black hole came too close, the sun could be torn apart entirely. The solar system would lose its anchor, and all the planets, including Earth, would drift into darkness. Fortunately, the chance of that exact path is very small. Still, even a near miss would leave permanent scars. The fate of the inner planets. As the black hole's gravity spreads inward, the inner planets would face their own nightmare. Mercury and Venus could be pulled from their orbits, colliding with each other or falling into the sun. Earth's orbit might stretch into an ellipse, causing extreme climate swings, scorching heat on one side, freezing cold on the other. The moon's orbit could shift, leading to massive tidal surges and earthquakes. If the black hole passed close enough, it could even tear away Earth's atmosphere, strip its oceans, or fling the planet completely out of the solar system. Imagine Earth cast adrift through interstellar space, a frozen world cut off from sunlight forever. If it passed through the solar system. What if the black hole didn't just pass nearby, but through the solar system itself? If it came anywhere near the orbit of Jupiter, the results would be unpredictable. Planets could swap orbits, collide, or be ejected. If it passed through the asteroid belt, millions of rocks would be scattered across space, bombarding inner worlds. If it passed near Earth, the consequences would depend on distance. A close pass might pull oceans upward, trigger global earthquakes, and shred the magnetosphere. A direct hit, though nearly impossible, would vaporize our planet in seconds, crushing it into a stream of superheated plasma spiraling into the black hole's core. In that moment, Earth would cease to exist, its atoms stretched into infinity. What about the black hole itself? A black hole passing through the solar system would not slow down. Its gravity is immense, but its size is tiny. A stellar mass black hole might only be about 30 kilometers wide, smaller than most cities. It would move straight through, unaffected, bending space and time around it as it went. After it left, it would take thousands of years for the solar system to settle again, if it ever did. Could we survive it? Could humanity survive a black hole encounter? Maybe, but not easily. If we had advanced warning, say decades, we might send warning systems and evacuation ships to the outer planets or build underground habitats powered by nuclear energy. But if the black hole came too close, survival would depend on pure luck. Even if Earth survived the gravitational chaos, our orbit might shift enough to end the climate stability that makes life possible. We could end up too far from the sun, freezing in endless winter, or too close, burning in heat. Civilization as we know it would almost certainly collapse. The good news, as terrifying as this scenario is, the good news is that it's extremely unlikely. The galaxy is vast and the distances between stars are enormous. Even though there are millions of rogue black holes, space is mostly empty. The chance of one passing directly through our solar system is incredibly small, perhaps once every trillion years. Still, scientists watch for signs. Gravitational lensing, subtle distortions in starlight, and irregular motions in distant objects could warn us if a black hole were heading our way. So far, nothing threatening has been detected. The closest black holes we know. The nearest known black hole is called Gaia BH1, about 1,160 light-years away. It's roughly 10 times the mass of the Sun, orbiting a normal star. That might sound close, but in cosmic terms, it's far beyond any danger. Even traveling at incredible speeds, it would take millions of years to reach us. But there could be smaller, undetected black holes much closer, especially primordial black holes, tiny remnants from the early universe that might weigh as much as a mountain but be smaller than an atom. These would be nearly impossible to detect, yet if one passed near Earth, we might only notice when gravity itself began to distort. What we could see if a black hole did approach, the sight would be hauntingly beautiful. As light bent around it, the stars behind would appear to stretch and twist into rings, a phenomenon called gravitational lensing. The black hole itself would appear as a perfect circle of darkness, outlined by distorted starlight. If it passed close to the sun, the accretion disk would flare, a bright, spinning halo of energy that could outshine every other object in the sky. It would be both terrifying and mesmerizing, the universe showing its raw power. What we could learn. Ironically, if humanity somehow survived, we would learn more about physics from that event than from any experiment ever built. A nearby black hole would allow us to study gravity, time dilation, and quantum effects on scales we've only imagined. We could test the limits of Einstein's relativity and explore how matter behaves under extreme conditions. In the middle of destruction, we would be witnessing the deepest secrets of reality itself. The nature of time. Near a black hole. If you were near the black hole as it passed, time itself would change. Gravity bends time, slowing it down near massive objects. An observer far from the black hole would see your movements stretch into slow motion, while for you, time would feel normal. If you cross the event horizon, the boundary beyond which nothing can escape, your journey would end in an instant. From your perspective, you might see the entire future of the universe unfold in a flash. From the outside, you would appear frozen forever at the edge of darkness. It is one of the strangest and most haunting predictions of physics. What the scenario teaches us. The black hole scenario reminds us how fragile and rare our solar system's balance is. A small change in gravity could destroy everything we know. The calm, steady orbit of our world is not guaranteed. It's a delicate arrangement that exists because the universe happens to be quiet right now. When we think about that, we begin to appreciate how precious stability really is and how small we are in the face of cosmic forces. If a black hole entered our solar system, it would be the most awe-inspiring and terrifying event imaginable. Planets would drift. Orbits would collapse. The sun could flare or fade, and Earth might vanish into darkness. But it also reminds us that the universe is not cruel. It's simply vast and wild. We exist in a calm moment between storms, protected by distance and luck. Every sunrise, every stable orbit, every quiet night sky is a miracle of balance. And somewhere out there beyond the stars, black holes continue to drift, silent and eternal, the dark hearts of creation.